Hello and welcome to Adder. So today we are solving a numerical based on the concept of cyclotron, a powerful device used to accelerate charged particles like protons. But don't worry, I'll break down each part of the solution so it's easy for you to understand. Now let's start with a quick question. Imagine you have a cyclotron with a magnetic field strength B of 2 watts per square meter and it used to accelerate proton. Now here is the question, can you figure out the frequency needed for the oscillator connected to the cyclotron? So if you are unsure, that's okay. Let's solve it step by step. First, let's focus on what we are actually looking for here. We need to find the frequency of the oscillator connected across the dees of the cyclotron. But why is this frequency important? Well, for protons to be accelerated smoothly in a cyclotron, the frequency of the oscillator has to match the frequency at which the protons spiral around within the magnetic field. To find the frequency, we have this formula. The frequency of the oscillator is given by the following expression: F equals to BE by 2 pi m. In this formula, F is the frequency we are looking for, B is the magnetic field strength, E is the charge of the proton, and M is the mass of the proton. Now let's break down each part separately. Alright. Let's start with the magnetic field, B. The problem tells us that B is 2 watts per square meter. A magnetic field in a cyclotron helps to bend the path of the protons, guiding them in a circular path as they accelerate. Think of it like how a track keeps a race car moving in a circular. Next, look at E, the charge of the proton. This is fundamental concept in physics that the charge of a proton is approximately equals to 1.6 into 10 to the power minus 19 coulombs. It's the positive charge that interacts with the magnetic field to produce a force on the proton. Finally, we have M, the mass of the proton, which is around 1.6 into 10 to the power minus 27 kilogram. Just as you will expect, the mass affects how quickly or slowly something can accelerate. A proton's mass, however tiny it is a critical part of determining the exact frequency that we need. Now let's understand each pattern. Let's plug in these values here. Here what it looks like when we substitute B, E and M into our formula. We have 2 into 1.6 into 10 to the power minus 19 by 2 pi multiplied by 1.67 into 10 to the power minus 27. Notice here that the 2 in the numerator matches the magnetic field strength B. The 1.6 into 10 to the power minus 19 represents the proton's charge and 1.67 into 10 to the power minus 27 is the proton's mass. Now, when we carry out the calculation, we find that the frequency F is approximately equal to 30.5 into 10 to the power 10 to the power 6 Hz or 30.5 megahertz. As it is 10 to the power 6, we can write it as megahertz. So what does this frequency mean? This frequency, 30.5 millihertz, is the rate at which the oscillator needs to switch the electric field in the D of the cyclotron. By matching the frequency, the cyclotron can keep pushing the proton along its circular path with perfect timing, which is at same. Adding energy to each cycle and boosting its speed, the circular path with the perfect timing, the cyclotron can keep pushing the proton along its circular path. Imagine someone pushing a swing in rhythm. Swing. With its natural back and forth motion, a swing swings. If they push at the right time, the swing goes higher and higher. That's essentially what the oscillator frequency is doing, right? So to sum up, we use the formula F equals to BE by 2 pi m and we substituted in the values of B, E, 2 pi and m to find out our answer, which is frequency equal to 30.5 into 10 to the power 6 Hz or 30.5 megahertz. This frequency is essential because it synchronizes with the natural rotation of protons in the magnetic field, allowing the cyclotron to accelerate them effectively. So that's it. By following these steps, you can solve any cyclotron frequency problem you came across. Remember, understanding the role of each part makes the math and physics easier to grasp. Thanks for watching and keep exploring the wonders of physics. Thank you.